For Fall 2022, Exam 2 for the course MA 16010. Let's begin. Number 1. Find the critical numbers of f of x equals 1/3 x cubed minus 3/2 x squared minus 4x plus a fifth. So when we're trying to find the critical numbers, we want to find where the derivative equals 0. So let's go ahead and find the derivative. F prime of x equals the derivative of 1/3 x cubed is x squared, because 1/3 times 3 is 1, giving us a coefficient of 1, minus the derivative of 3/2 x squared is negative 3x. The derivative of negative 4 is negative 4x is negative 4, and the derivative of any constant equals 0. And now we're going to set this whole thing equal to 0. So, looking at the equation we have for this derivative, to find where the x equals 0, we need to factor. So let's go ahead and factor this. X minus 4 and then x plus 1 equals 0. When we solve these two bits where we set x minus 4 equal to 0 and x plus 1 equal to 0, we would get that x equals 4 and x equals negative 1, giving us an answer of A. Okay. Number 2, find f prime of 2 given f of x equals the natural log of x squared over 2x plus 1. So two main concepts we're dealing with here. We are dealing with chain rule and quotient rule. So we can see we're going to use quotient rule because we have one function divided by another inside of this natural log, and we're going to use chain rule because this function, natural log, has something other than x in those two parentheses. So let's go ahead and start with quotient rule, or the inside. When we do chain rule, I like to start from the inside and go outside. So let's start with the inside stuff first. So let's go ahead and label the numerator G and the denominator H. As a reminder, quotient rule is H times G prime minus H prime times G over H squared. Now, we can go ahead and find G prime and H prime. G prime equals the derivative of x squared, which is 2x, and h prime equals the derivative of 2x plus 1, which equals 2. Now, if we plug all of this back into the equation for quotient rule, we would get that h, so that's 2x plus 1 times g prime, which is 2x, minus h prime, which is 2 times g, which is x squared, all over 2x plus 1 squared. Now, let's deal with this natural log. As a reminder, the derivative of natural log of x equals 1 over x, which means that the derivative of this function would be 1 over everything that's inside. So that would be x squared 2x plus 1. Now, we need to multiply this by the derivative of this, which is what we found using our chain rule. So I'm going to go ahead and move this down to match. And this whole thing is our derivative. It's just not in a very simplified form. So let's go ahead and simplify this. F prime of x equals 2x plus 1 over x squared times 2x plus 1 times 2x minus 2x squared over 2x plus 1 squared. We can see that in the numerator of the left term and the denominator of the right term that there's a 2x plus 1. So let's go ahead and cancel the top one and lower the power of the denominator. Now we can go ahead and plug in the point of 2 in here to solve for our answer. So let's solve for f prime of 2. If we solve for f prime of 2, we have 1 over 2 squared times 2 times 2 plus 1 times 2 times 2 minus 2 times 2 squared over 2x plus, not 2x, 2 times 2 plus 1. That's a lot of 2's. Let's go ahead and simplify this. This would be 1 over 4 times 2 times 2 plus 1 is 5, 2 times 2 is 4, 5 times 4 is 20, minus 2 times 2 squared, which is 2 times 4, is 8, and then all over 5. So 20 minus 8 is 12, over 4 times 5 is 20. Divide that whole thing by 4 to simplify, and we get an answer of 3/5, or C. Okay, number 3. Find the derivative of f of x equals e to the 2x times sine squared x. Looks like I spelled the word derivative wrong in my transcription. Sorry about that. So, in this problem, we can see that the function we are given has two very clear functions times each other. So, we'll need to use product rule. As a reminder, product rule is g prime times h plus g of 8 times h prime. Okay, let's go ahead and find g prime and h prime if g equals 2 e to the 2x and h equals sine squared x. So g prime equals the derivative of e to the 2x. Now, when we do this, we also notice that this needs chain rule. The derivative of the thing that is e to the e is set to is 2, so the derivative of 2x is 2. So we can move that out, and it would be 2 times e to the 2x as our derivative. So again, let's do it with h prime. H prime equals d, the derivative of sine squared x. So again, we use chain rule. We use power rule first, so we're going to move this 2 out to the front. So it'll give us 2 sine x, and then we need to find the derivative of sine, which is cosine x, giving us h prime equals 2 sine x cosine x. Now it's as simple as plugging in g prime and h prime into the original equation with g and h. So let's go ahead and do that. G prime is 2 e to the 2x times h, which is sine squared x, plus g, which is e to the 2x, times h prime, which is 2 times sine x cosine x. As we can see from the answers, this isn't quite, what we have right now isn't quite formatted to be an answer. But we see a lot of these parentheses with common terms outside in almost all these answers. So let's go ahead and try to find common terms. We can see that 2 e to the 2x and sine are common things between the two terms. So if we take those out, we would get 2 e to the 2x sine x times sine x plus cosine x. This matches up with one of our answers. This gives us the answer of B. Number 4. The radius of a sphere changes at a rate of 2 inches per second. What is the rate of change of the surface area of the sphere in inches squared per second when, another misspelling, when the radius is 3 inches? The surface area of the sphere is given by the formula. So when you're given something changing with respect to another thing, we call that a related rate. So to find a related rate, we need to use implicit differentiation. So we're going to find the derivative of the surface area of a sphere. So the surface area of a sphere, we would get S prime, and S prime equals the d of the surface area over dt. So that's ds over dt for the rate of change of the surface with respect to time equals 4 pi times the derivative with respect to time of r squared. So if we find that, we need to use implicit differentiation. We would find that this term right here would be 2r times dr over dt, because we don't know how radius changes with respect to time, we just have it as a rate. So we rewrite that. Now, in the problem, we are given that the radius changes as 2 inches per second, and that we're trying to find the rate of change of the surface area when the radius is 3 inches. So these are all given values. So if we plug those in, 4 times pi times 2 times the radius is 3 times the rate of change is 2 inches per second. So if we simplify this, we get 4 times 2 times 3, so that's 8 times 3 is 24, times 2 is 48 pi, giving us a rate of change of 48 pi. So that is an answer of F. Okay, number 5. The position of an object moving on a straight line is given by S of t equals 48 minus 3t minus 2t squared minus 6t cubed, where t is in minutes and S of t is in meters. What is the acceleration when t equals 3 minutes? So, as a reminder, acceleration equals d, the derivative of v of t, and velocity equals the derivative with respect to time of position. So to find the acceleration, we need to find the velocity, and then we need to find acceleration with the derivative of the velocity. So let's go ahead and begin by finding velocity. Again, velocity equals s prime of t, which equals, from this s prime of t, the derivative of 48, it's a constant, so that's 0. Derivative of negative 3t is negative 3. Derivative of negative 2t squared is negative 4t. And then derivative of negative 6t cubed is negative 18t squared. Okay, now to find the acceleration from this, acceleration equals v prime of t, which equals negative 3 is a constant, so the derivative of that is 0. Derivative of negative 4t is negative 4. Derivative of negative 18t squared is negative 36t. So we're going to try to find the acceleration when t equals 3 minutes. So we just plug in 3 for t. So that gives us a of 3 equals negative 4 minus 36 times 3, which if you plug into your calculator equals negative 112 meters per minute squared, or d. Whoops, there we go. Okay. Number 6. Use implicit differentiation to find dy dx given 2xy equals y cubed plus 3 at the point 2, 1. So whenever we take the derivative of x, we don't need to add an extra term, but when we do implicit differentiation, we need to add a dy dx for every time we find the derivative of y. So we can see from this term on the left that this will be product rule because it's one thing times another, and on the right it should just be regular differentiation. So let's go ahead and start with the product rule side. If we say that 2x is g and y is h, we remember that our product rule definition is g prime times h plus g times h prime. If we find g prime equals the derivative of 2x, which equals 2, and h prime, the derivative with respect to x of y, equals dy dx. So now we just plug it back into this equation, and we get 2 times h, which is y, plus g, which is 2x, times dy over dx. Now to do the other side, the derivative with respect to x of y cubed equals 3y squared dy dx, because we don't know how y is a function of x right now. And then the other term, 3 plus 3 is a constant, so the derivative of 3 is 0. When we set those two we're going to set these two equal to each other, so that would be 2y plus 2x dy dx equals 3y squared dy dx. We want to find what dy dx is, so we need to isolate dy dx. So I'm going to move this term to the right side. That would give us 3y squared dy dx minus 2x dy dx equals 2y. Now, let's go ahead and pull out the like term, which is the dy dx. So dy dx times 3y squared minus 2x equals 2y. If we divide it out, we get that dy over dx equals 2y over 3y squared minus 2x. Now, this question asks us to find it at the point 2, 1, so all we need to do is plug in 2 for x and 1 for y. So we would get 2 times 1 over 3 times 1 squared minus 2 times 2. So if we simplify this, we would get 2 over 3 minus 4, which gives us 2 over negative 1 or negative 2, giving us an answer of C. Number 7. The function g of x equals 2x cubed minus 15x squared minus 30 has a relative local minimum at which of the following x values? When we're looking for local minimums or maximums, the fastest way is to use the second derivative test. So we got to first start by finding the critical numbers for the first derivative and then plugging them in to the second derivative to find the concavity. So let's go ahead and find the first derivative. So g prime of x equals derivative of 2x cubed is 6x squared minus derivative of 15x squared is 30x, and then the derivative of negative 30 is 0. So we want to set this equal to 0 to find our critical numbers, and we would get, if we take out an x, 6x, we would get 6x minus, or times x minus 5 equals 0. If we solve that, we would get that x equals 0 and 5. Now, let's find the second derivative so we can do the second derivative test. G prime of x or g double prime of x equals derivative of 6x squared is 12x, derivative of negative 30x is negative 30. Now, let's go ahead and plug in these 2 points to find the concavity. So g double prime of 0 equals 12 times 0 minus 30, which equals negative 30. This is negative, so this means that this is concave down. Now let's go ahead and do the other point. G double prime of 5 equals 12 times 5 minus 30, which is 60 minus 30, which is 30, and this is positive, so this is concave up. Now, the way I like to remember concavity is to draw my smiley faces. So if it's concave up, it has a local minimum, and if it's concave down, it's a frowny face, it has a maximum. So, because we can see that g prime of 5 gives us a point at which is concave up, we know that our minimum is at x equals 5, which gives us an answer of E. Number 8. A baseball diamond is a square with 90 feet on each side. A player runs from first base to second base at 11 feet per second. At what rate is the player's distance from home base increasing when he is halfway from first to second base? So we were really lucky. They provided us this beautiful diagram. So let's go ahead and mark distances to make this a little bit easier to see. We can see that this distance right here is halfway, so between the two bases, that would be 90 divided by 2 equals 45. And this distance over here is the full distance, which is 90 because it's a square. Now, this is a triangle. So we are trying to find at the rate at which the player's distance from home base increases. So we want to find how much this length, the hypotenuse, or I'm going to label it C in this case, is increasing with respect to the two other lengths of A and B. So another thing of note is that A will stay fixed the entire time in this problem, and the only thing that is changing is this side, this B side that I've labeled. So we need to find the rate of dB over dt. So let's go ahead and set this up. This is a triangle, so we're going to use Pythagorean theorem. C equals the square root of A squared plus B squared. So, and I got this from C squared equals A squared plus B squared. If we go ahead and plug in 90 for A, you get C equals 90 squared plus B squared. Again, this 90 squared, or this 90 is from this length right here. Now, we want to find the rate at which the distance changes from home base, so that would mean we need to find the derivative of c. The derivative of c is dc over dt, and then we need the derivative of this, which is the 90 squared plus b squared. Now, to find the derivative of b, this whole thing, we know that b has to be with respect to t, so again, we're going to use implicit differentiation to put a rate of b in there. So, we find the derivative of this, we would find that this is a chain rule question. So, the derivative of a square root, I like to write my square roots like this. The derivative of a square root equals 1 over 2 square root of that thing. So, let's go ahead and do this. We would find that this equals 1 over 2 square root of 90 squared plus b squared. Now, there's something inside of the square root other than x, so we need to use chain rule. So the derivative of the stuff inside equals the derivative of 90 plus b squared. 90 is a constant, so that would be 0. And then b squared would be 2b, it should be multiplied, times db over dt, again, because b is a function of time. Now, let's write this a little bit neater. dc over dt equals 2b db over dt over 2 square root of 90 squared plus b squared. Now let's simplify this a little bit. We can cancel out the 2's. And then we're trying to find it when the player is a distance halfway between the two bases. Plus, we know that the player's rate from first to second base is 11 feet per second. So let's go ahead and plug in those two numbers. We get that b is 45 times db dt is 11 feet per second over 2 square root of 90 squared is 8100 plus b squared is 45 squared because halfway between, or half of 90 is 45. If we simplify this, we would get 495 over the square root of 10125. I'm going to go ahead and move this over so we have a little bit more space, which equals 495 over square root of 5 times 2025, which equals 495 over, let's see, 5 times 45 squared, and that equals 495 over 45 times 1 over root 5, which simplifies to 11 over root 5, which gives us an answer of F. It's a really long question. Okay, number 9. Choose the correct statement regarding 1/3 x cubed plus 3x squared minus 7x plus 1. So we should look at the answers to determine the correct answer for this one, because we're looking for a common theme between the answers. We can see that all of these answers have something to do with concavity. Now, to find where a function is concave up or concave down, we need to use the second derivative. So let's go ahead and find the first and second derivative to find our inflection points and our critical points. So let's go ahead and find f prime of x, which is this function, f prime of x equals the derivative of x 1/3 x cubed is x squared plus derivative of 3x squared is 6x, and then derivative of negative 7x plus 1 is negative 7, and then derivative of a constant again is 0. Let's find the second derivative. F double prime of x equals derivative of 2x is, or x squared is 2x, derivative of 6x is 6, and then negative 7 is a constant, so that will be 0. To find where our inflection points are, or where our concavity can switch from concave up to concave down, or vice versa, we need to set the second derivative equal to 0. So let's go ahead and do that. If we solve this equation right here, we would find that the 2x equals -6, and then x equals -3, giving us an inflection point of -3. When I'm looking at concavity, I like to draw a number line to keep things straight. So let's go ahead and do that. So I've marked our one inflection point. From this point, we can actually go back to the answers real fast. Anything that says 2 inflection points can't be the right answer because we only found one inflection point. So wrong answers include A, C, and D. Okay, to find where a function is concave up or concave down, we can use the points surrounding this. So let's use -4 and -1 because those are pretty simple numbers. So let's go ahead and plug -4 in f double prime. So f double prime of -4 equals 2 times -4 plus 6, which this equals -2. So we know that because the second derivative is negative, that the left side, anything to the left of this -3 is concave down. Now, let's do the same for the right side. Again, you can use any arbitrary point as long as it's not equal to 3. F double prime of -1 equals 2 times -1 plus 6, which equals -2 plus 6, which is 4. Now we know that's positive, so again, that's going to be concave up. So when we look at the options, we can see that these are all asking for concave up, so the only interval we're concerned about is anything greater than -3 or greater. So when we look at the options, we can immediately cross out B because -7 is not even in there. And so we're left with E and F. Again, if we look at the number line, we know it's concave up when the x is greater than -3, which means our answer has to be E. Okay, number 10. Identify the relative local maxima of the function shown in the graph below. When we're given a graph, it's super simple. You just look for the peaks and the dips. For maxima, we're looking for any high peaks. So we can see on this graph that that would be right here and right here. If we draw the points from the points to the line, we can see where the points are more clearly. We can see that this left point is at -4 and 4, and this right point is at 3 and 5. When we look at the answers, that gives us, looks like D. 2 more questions. Number 11. F of x is a polynomial and f prime of 1 equals 0, f prime of 4 equals 0, f double prime of 2.5 equals 0, f double prime of x is less than 0 for x is less than 2.5, f double prime of x is greater than 0 for x is greater than 2.5. So which of the following statements is true? That was a bit of a mouthful, but essentially, let's go ahead and break down each of these equations first. These first 2 points right here, they're the derivative set equal to 0. Like the first question, when the derivative is equal to 0, those two numbers are critical numbers. So wherever x, or whatever x value makes the derivative equal to 0 is a critical number. So these 2 points up here are critical numbers. Now for this whole second line, this has everything to do with the second derivative. So I want to look at this leftmost statement first. F double prime of 2.5 equals 0. Whenever the second derivative equals 0, that x value is an inflection point. So we're going to label this as an inflection point. Now for these other two statements, these relate to the concavity because they are around said inflection point. So this says that f double prime of x is less than 0 when x is less than 2.5. Because of this, we can say that negative infinity to 2.5 is concave down, because again, f double prime of x is less than 0, making it negative, which is concave down. This other statement says the opposite, when f double prime of x is greater than 0, when x is greater than 2.5. That means that we can say that 2.5 to positive infinity is concave up. Now let's go ahead and look at these statements now that we've broken down every single one of these statements in the top. Number 1 f of 1 is an inflection point of f of x. We know from the statements above that this is false. Again, our only known inflection point is this x equals 2.5. Number 2, 2.5, f of 2.5 is an inflection point of f of x. We just said this because we said the second derivative set wherever x plugged in, whatever x value makes the second derivative equal to 0 is an inflection point. So this second statement is true. Number 3, f of x has a relative maximum at x equals 1. So when we look at x equals 1, right here, this first value, we see that it fits into this first interval right here, where from negative infinity to 2.5. So let's go ahead and draw a number line to make this a little bit easier to see. This is concave up, and this is concave down. It's concave up, concave down. We can see that where x equals 1 would be right here. Because this section, negative infinity to 2.5, is concave down, we can see that it's a relative maximum. So that's true. Now, number 4, f of x has a relative minimum at x equals 4. So again, on our little number line, if we put 4 here, we can see that is in the section that is concave up. If we draw what a curve that looks concave up is, we can see that our little smiley face has a local minimum, making number 4 true. So that gives us 2, 3, and 4 as true, which gives us an answer of C. Last question. Choose the correct statement about the absolute minimum and absolute maximum of f of x equals x to the fourth minus 4x on the interval of 0 to 2. So we're going to try to find the critical numbers of this by using the first derivative. So f prime of x equals derivative of x to the fourth is 4x cubed minus derivative of 4x is negative 4. Now, critical numbers are when the derivative equals 0, so let's set this equal to 0. And we can find that x would equal 1 here. Okay. Now, we know that this is a critical number, but because this is on a closed interval, we also need to check the ends of the interval to make sure that those are not the minimum and maximum, because this are local min min or maximum, because it's not obvious with the first derivative test. So if we go ahead and plug those in, we would get that f of x equals, or not f of x, f of 0 equals 0 to the fourth minus 4 times 0 equals 0. Let's check the other side too. F of 2 equals 2 to the fourth minus 4 times 2, which is 16, minus 8, which is 8. And then this last value here, we're going to check the critical number in the middle, the one that we do know from finding the first derivative. F of 1 equals 1 to the fourth minus 4 times 1, which is negative 3. So all of these values right here are critical points of this function in the given interval. Again, when you're given an interval, you need to check the ends to make sure that there's no maximums or minimums that we can't find using the first derivative. So this question asks for the absolute minimum and absolute maximum. As we can see from here, the absolute minimum would be this, and the absolute maximum would be at 2. So the minimum is 1, -3, and the maximum is 2, 8. That looks like an answer of A.